Let's look at, this is the alternative question for final 2. Draw the shear and moment diagram for the beam. So you have this beam. The support at A and B are thrust bearing and journal bearing respectively, which means that A has AX, AY and B has only BY. So this is the only meaning of for thrust bearing and journal bearing respectively. Okay, let's look at this beam. 600 Newton down, and here there's BY, and there's 1200 Newton per meter uniform distribution, and 300 Newton that way. And there's AY, AX here. And again, for the shear moment diagram, there is no need to find AX, even though you could see that AX here is 0, since there is no force in the X direction. The best is to put the reactions. So let's put the reactions. 300 Newton, and we did put AX and AY, and then he called it BY or MB, whatever. So the reaction here is only one reaction, the Y, and 600 Newton that way. And the uniform, it's 1200 times 1. 1200 Newton per meter times the distance of this uniform. 1200 times 1. So we found it like this. From this we could find out summation of moment at A to cancel out AX and AY. You could find NB, or you could find BY. And then summation of force at the Y, you could find NB. Or you could find summation of moment at B to find AY. So he did find it like this, summation of moment at A. And from this summation of moment at A, he found out the BY, or normal force at B, 1350. And summation moment at B at the other side. You could do summation of forces at the Y and you could find AY easily, but he did summation moment at B. It's up to him. It's gonna give you all the same answer. So AY is 750, and the summation force at the X, there is no force in the X axis, so AX. So we have right now MB 1350 and AY 750. Now from this you put it in the figure like this: 750, 1350, and this is the uniform distributed. You figure it like this, and then let's do the shear diagram first. You put Vn, remember it's Newton, so shear means Vn, and then X is in meters. So let's start from this point. It's 300 Newton down, so it's minus 300. And here there is no loading, so it's gonna go uniform all the way until it reaches this point. Here there is a 750 up. So minus 300 plus 750, minus 300 plus 750, you'll go plus 450. And again, we said that if there is no loading, it's uniform. If it is uniform loading, now it's going to be what? Linear. So here is plus 450, and here there is a uniform loading, so 1200 times 1, so 450 minus 1200, you will go all the way down, it's linear by the way, to minus 750. So here you see that there is 1350 up, so minus 750 plus 1350, you'll get 600. So here, look at this, there is no loading here, so it's going to be uniform until 600 down, 0. Shear, like these type of beams, it should start from 0, goes back to 0. This is a good check. Now, in order to find the moment, we have to find the area under the shear. So this is very simple. Minus 300, this is here, and 0.5, so it's minus 150. Let's do this later on. This is 600 and 0.5, 600 and 300. So minus 150 and 300. Now, let's find the area under this curve. So how could we do it? Remember, this is 450 and this is minus 750. So the total triangle, 450 plus 750, so you could do the total triangle, 1200 and 1 meter. So if you make the whole side of the big triangle, 450 plus 750, it is 1200. And the whole distance is 1 meter. Let's take the small triangle, 450, and we need to find this X. I know I found the answer here, 0.375, but let's find this X. Okay, 450 and X. So 450 and x and 1201. So x over 450, because they are both the same triangle. This is the big triangle and this is the small triangle. So they're all the same triangle. We could do this theory, or we could do this method to find out this x. X over 450 equal 1 over 1200. So 450 over 1200, x is equal to 0.375. So we found that this is the x, 0.375. So what is the remaining here? It's 1. So 1 minus 0.375 is equal to 0.625. Now, how could you find the area here? It's a triangle. So 1/2 times 450 times 0.375, it will give you 84.375 plus. And this is 750 in the minus. 1/2 times 750 times 0.625, you'll get minus 234.375. If you find the areas, now the moment would be easy. Remember, if there's no loading, the shear is uniform. If there is normal or uniform loading, the shear would be linear. No loading, uniform. Now, if you have a uniform loading shear, the moment gonna be linear. So here, you could look, this is the moment, minus 150. So you go, and first of all, you do moment, Newton meters, and x meter. Now here, I did not finish this, so I'll try to finish it from here. Okay. So this is, what is this? Minus 150. Minus 150 Newton meter. This is the moment. Okay? Minus 150. Now, what is the next one? The next one is a linear. If you have a linear shear, the moment going to be concave down. So now, look at this. 84.37, it's a plus. So you add up minus 150 plus the next. Remember, there is we have to have a change of moment. This is the point where there's zero shear. You have to have a change of moment. It's not going to be a continuation, because here there's two triangles. So you have to find this area and this area. And this point, zero shear, there is a change of moment value. Okay, so what will happen later on? So we have minus 150 plus 84.375 minus 150 plus 84.375 would give you minus 65.25. So the answer would be minus 65. And it is, here it's linear, so this is going to be concave down moment. This is minus minus 65.6. Okay, you also has this minus 234.375 in the minus, and you have minus 65.6, so minus 65.625. Well, this is going to be minus 65. Okay. Minus 234.375. Remember, minus 234.75. Now, this is linear, so it's going to be another concave down. So this is minus 300. So you're going to go minus 300. This is 150. So it's going to go down a little bit down. Minus 300. And this is linear, so this is going to be concave down. So this is going to be concave. It's not linear. It's concave down, minus 300. And of course, here there is no moment, so it's going to be 0, going to 0. So minus 300 and plus 300. But remember, this is uniform. So what are you going to have moment? You're going to have moment linear. So minus 300 plus 300, that's 0. Linear, not concave down, linear. So this is the easiest problem that we could face. Easy loading, find the reactions, find the shear diagram, and then find the moment diagram. Very simple.